Good morning. This is again Amit Kumar, and this is my digital assignment 2 on computer organization and architecture. And this was the digital assignment in which we have to analyze a floating point unit from any open access journal, and using this paper, we had to answer the 10 questions. So, to begin with, I have took a paper, journal paper on the topic a novel heterogeneous approximate multiplier for low power and high performance. And this is the link by using which you can go through the paper also. So let's go through the questions. First questions, it's about explaining how the selected paper is relevant with the COI. So approximate computing, like I have took approximate multiplier. So approximate computing is a design paradigm considering for a range of application that can be tolerate some loss of accuracy. So in this paper, a new architecture that engages accuracy as a design parameter is presented, where an approximate parallel multiplier using heterogeneous block is implemented. Based on the design space exploration, they have demonstrated that introducing diverse building blocks to implement the multiplier rather than cloning one building block achieves higher precision result. Second question is about drawing the existing architecture using any graphics editor software. So I have used draw.io, which is very simple to use, and this is the diagram for that. And this is the diagram of approximate adder design using CPL logic, where you can see 3 XOR at the top and 2 XOR at the bottom, and there is a AND logic, and these are the inputs and this is the output. This is the existing paper architecture. Then come to the third question. Third question was drawing all the tables and graphs using Office Suite, but I have just used MS Word to draw all these graphs, and you can see the table also. In this paper they have used mean square error metric to access the quality of different approximate filter compared to the reference output. The results shown in the table demonstrate that the proposed multiplier filter is much more accurate, and this graph also shows those results. Like this graph is about relative number of transistors and all the 4 proposed multipliers, and this graph is the delay in nanosecond and all the uh, in XA1, in XA2, in XA3 conventional and proposed architecture. This graph is about the number of errors by bit and the output bit, and this paper is all those structures and the energy in Fermi joules. And the fourth question was draw the proposed architecture discussed in the paper that I chose, that is the novel heterogeneous approximate multiplier for low power and high performance. The tool again I have used draw.io, which is again a very simple tool. You can see the structure. There are multi-level multipliers. This is the inputs, and finally we'll get the output. And you can see each block has one AND gate and a full ladder. Then This is the proposed architecture that was there in the paper. Coming to the fifth question, it it has the uh, in this we have to draw the transistor level internal diagrams using the electronic schematic capture. Here I have drew the logic diagram of in XA1. This is the logic diagram in XA2 and this is logic diagram in XA3, and these are their transistor circuits respectively. Again, in sixth question, we had asked to compare the proposed architecture with existing architecture that was there in the book. So in this paper, they have proposed to rely on the set of different intact elementary block instead of one block that is replicated to build a desired circuit. The purpose is to take the advantage of design flexibility given by the diversify the approximate element to comprehensively benefit from the error masking mechanism, thereby reducing the precision loss. More specifically, the logical masking mechanism that is applied where an error propagates to reach a gate input with another input is in the controlling state. Hence, the idea is to explore a design time, the set of intact in implementation to identify those with minimum number of errors. Then the seventh question is about listing the advantages of proposed design. So I have listed two advantages. First one is the implementation of my proposed multiplier costs only 35% of the number of transistor used in exact multiplier. Second one is the paper that I chose and the multiplier that was proposed outperforms the two in XA1 and in XA3 based approximate multipliers in terms of performance metrics. And even there is a delay overhead compared to in XA1 based circuit. In XA1 based multiplier consumes 24% more energy than the one proposed multiplier. Sorry. So again, in question 8, it was given to list the merits and demerits of proposed and existing multiplier. There is not much demerits of this proposed multiplier, though we can see the merits proposed novel heterogeneous architecture uses accuracy as a design parameter. Introducing different elementary architecture to implement the circuit leads to a lower rate compared to existing design. The proposed design benefits from the masking mechanism within the logic element in different cases to limit the overall deviation from the exact result, and so on. In the question 9, it has been told to list the application of proposed design. So with the increase in amount of data and complexity, we know that the battery operated in electronic devices, there's continuous for design technique to conserve power consumption while achieving the desired performance. So it impacts directly the computing paradigm due to the new specific demands in the application, which are not necessarily aiming at the precision numerical results. Instead, they try to achieve the sufficient quality of results. This design helps us to resolve these all problems. Again, in question 10, we had told to draw the flowchart or the algorithm or the transistor level proposed. So uh, I have listed here the algorithm of the multiplier that was proposed. Here we can see There are 3 steps of this algorithm. The objective is to find the combination of full adders that minimizes the minimum error distance for all over the design, where MED is the uh, average arithmetic deviation from the accurate design. The idea is based on genetic algorithm, exploration algorithm, and adapted to our design problem. The exploration process is achieved in 3 steps corresponding to the architecture of full adder lines. And you can see the algorithm for exploration to minimize the minimum error distance. This is the basic idea of our proposed paper, to minimize the minimum error distance. Thank you for the patience listening. Do share, like and subscribe.